that. And so this time we actually were able to schedule it and not have 3 snow days in between. So that was but apparently they're calling for a potential snow day tomorrow, so we'll see. But, well, we'll see. They're calling for. But remember last time they were calling for a big snow day, and we had like that one like rain of snow. So no promises. However, what's going to happen is this timing is absolutely perfect. We were talking about stewardship, and we just finished watching Life After People and talked about the long-term prediction if humans weren't involved. And I know that we're working on the green screen, and you're doing your Georgetown After People. And so the timing couldn't be more perfect, because Dr. Mark's going to talk to us a little bit about the truth about the science of global warming. Because we see a lot in the media, especially, for example, a couple of years ago when Trump brought up in the election saying, no, it's just a false idea, it's a lie brought up by the Chinese, and people buy into it. And there is natural ebbs and flows, but we're very fortunate to have an expert come talk to us about a lot of the stuff. So obviously, you will have lots of questions, and Dr. Mark's a really awesome guy, and he will definitely, no doubt, have time for those questions. But he'll tell you when he wants those. So let's just make sure that. And you know what? Just as Dr. Rick did, Mark took a day off work for us. So it's amazing that he was able to give up that time, and obviously we'll show him that time by listening to his content and then asking great questions. And I know you'll have lots of great questions. So let's all welcome Dr. Mark.
Thanks, Sean. Appreciate it. Really nice intro. I didn't know about that part about Trump saying that it was the Chinese that made up global warming. I guess for their benefit, but I guess learn something new every day. So yeah, I guess add on to that. I guess what I'm going to talk about, I'm going to talk a lot about facts, and I'm going to present a objective side, which I guess means showing the facts behind the situation, and then I guess you can make your own conclusions based on the data I show you. So there's going to be a lot of information going. I'm going to go kind of quick, but I'm going to take the time to write down some of the main points of what's the takeaway message from this presentation. So let's get to it. So I guess I'm going to talk mainly about carbon dioxide and I guess records, how we know temperature and carbon dioxide over the past 50 years, 100 years, even back to 400,000 years and even older. So I guess that's really cool technology. It's the first time I've seen that. So a bit about me. I guess the reason why I put this up is not to say like this is who I am. I guess it's to say this is the path I guess I went down, and if you are interested in I guess what I present to you today, then this could be a path that you guys can go down too, and you guys can do this too. I did some research in Brazil. I spent some time in Brazil from 2011 to 2014, and I'm telling you this because the way that I found that was I had graduated from University of Toronto with a Bachelor of Science, and I knew I wanted to go into research, right? And I went online and I found a posting saying graduate student opportunity Ph.D. with research in Brazil. And so I said, yeah, I want to go to Brazil. I want to do that, right? I love tropical forests. This is my thing. So I applied. I asked. That was the thing, right? Like you go out there and ask. If you see something presented and says it's an offer, go out, ask. You can do it, right? Because the professor said yes, and it was a good fit. And yeah, you guys can definitely do it too if you like this. I guess what I'm going to show you. So I guess to get into it. I guess part one is just going to be about CO2 and the climate record. Part two is going to be warming and CO2 enrichment experiments. And when I say CO2, I mean carbon dioxide, which is a greenhouse gas. Have you gone over greenhouse gases a little bit? Yeah? Okay. I'll talk a little bit about that and then a little about my research. So let's get into it. So part one, CO2 and the climate record. Going to talk about our, I guess, sophisticated scientific methods, right? Anyways, it was a dry joke anyways. All right. So I guess the first distinction and difference that I want to talk about is weather versus climate. And basically, I guess, weather and climate are different things, where weather is more of a, I would say, a day-to-day type of scenario, right? Where, you know what, I'm going to write this down. So weather occurs on a day-to-day scale. I write very poorly, by the way. So I don't
They're used to it, sir.
Yeah. So day to day, and climate actually works on a year to year or millennia, so a much larger time scale. And actually, climate is much more predictable than weather. And the reasoning is because over time you get balancing, and so it's really hard to predict the weather for the next day or even the next week, but it's pretty easy to predict the amount of rain that's going to fall in an area over a year. A good analogy, I thought of this on the way here, Sean, is in baseball. It's like when you're up to bat, like with the pitcher, right? You know that the pitcher is going to throw maybe, I don't know, maybe 50 fastballs, maybe 30 curveballs, and maybe, I don't know, 10 changeups or 10 sliders, whatever, over the game, right? But when you're up to bat, you don't know what he's going to throw next, right? So that's kind of like a weather, climate type of analogy that I understand. I'm sure maybe Sean can understand too, right? So it's easier to predict climate over a long period, whereas weather is a little more harder to predict day to day, right? So greenhouse gases, these are the main ones, carbon dioxide, and you can see, I don't know if you can see the percentages, maybe it's a little small, I don't know. What you can see is carbon dioxide, these are this isn't the amount in the atmosphere, but this is the actual influence of these gases to global warming, or rather the greenhouse gas effect and warming. So you can see that carbon dioxide represents about 50%. Here methane is an important one also, but only represents about 18%, even though per molecule it has a much greater warming effect. There's less of it in the atmosphere, so the carbon dioxide effect is larger. Again, I'm going to go through this fast. You don't have to worry. Don't even have to worry about the numbers on this graph. Just look at the fact that that incoming solar radiation from the sun, some gets absorbed, some gets reflected. That's pretty much all I wanted to show with that. But I think you guys went over global warming or greenhouse gas effects. So this graph is actually one of the important ones. And what you can see, this is on the left, is the amount of carbon dioxide in the atmosphere. And this is through time. And you can see that it's been linearly increasing through time. And this is actually consistent across the world. And I'll just fast forward a little bit. So these are different places around the world. Like the South Pole shows here in the green. Mauna Loa is Hawaii, is the blue. And you can actually see that through time, everywhere in the world, the CO2 amount is the exact same everywhere. What you can see is that the South Pole, there's very little fluctuation. And say like Mauna Loa and Barrow, there's much greater annual fluctuation. And do you think anyone can identify why there's this up and down effect per every year, that where it goes up and down? Yeah, sure.
Is it CO2 kind of moves between different places in the world at different times?
No, not exactly. That's it's actually the amount of CO2 is kind of similar everywhere. It's related. I would say I would give a hint maybe. Actually, wait. Yeah, okay, I'll give a hint. Actually, no, if I give a hint, it'll give it away. But it's related to that was a good guess though, because this is why I wanted to show this graph, because some people think that CO2 differs in different places in the world, but it's actually pretty similar in around the world. And so your name is?
Eric.
Eric, nice. Nice to meet you, Eric. Nice. So, thanks for the contribution.
Shake your hand kind of far away.
Sorry?
I'd shake your hand.
No, for sure. Good, nice. So, okay, I guess there's a lot of slides, so I'll tell you why it's like this. It's because of what's it called? Seasons. And in the northern hemisphere and southern hemisphere, there's a lot of intake of carbon dioxide right in the summer, and then in the winter there's not that much carbon dioxide intake. That's why in the South Pole you see there's not as great fluctuation, because there's not that effect, which I guess does tie into what you had said, because it does vary based on location around the world, right? Actually, it does. It literally does. Sorry, I was incorrect. You were correct, Eric, because there is that variation through in space. So, yeah, based on plants, though. So, plants